Hey guys, Professor Calculus is here. Today in this video we're gonna prove a more general form of Glasser's master theorem, which I wrote here, the f of x minus a over x, with respect to x from negative infinity to infinity, and we want to see the behavior of this integral and what does this integral finally become. So it's a useful identity in calculus, but before that, make sure to like and subscribe, as it is free and you can always change your mind later. So first of all, the step one here, I'm gonna let u be equal to x minus a over x, and u therefore is x squared minus a over x, and therefore ux is x squared minus a, and thus it would be x squared minus a minus ux equals 0, which is x squared minus ux minus a equals 0. Now recall the quadratic formula that was x equals negative b plus or minus root b squared minus 4ac over minus b squared minus 4ac over 2a. Now if I plug in the variables that I have here, my x is going to be u negative u plus or minus root negative u squared minus 4 1 times negative a over 2 times 1, and x is going to be u plus or minus root u squared plus 4a over 2. So I'm gonna do some factoring out here. I'm gonna say x equals half times u plus or minus root u squared plus 4a, and if I do some differentiate both sides, I'm going to be having dx to be equal to half 1 plus or minus u over root u squared plus 4a du if I use the chain rule, and you'll see that I'll get these results. Now the attention that we should pay here is this plus or minus. Should we choose plus or minus root? So first of all, let me write this integral again that we wanted to resolve. F of x minus a over x dx equals, I'm gonna write it as this expression 0 to infinity of f of x minus a over x dx. So I need to pay attention to my bounds. If well, I can well, let's first of all do this substitution here, and then we will worry about the bounds. Half f of u 1 minus u over root u squared plus 4a du plus the integral of half f of u 1 plus u over root u squared plus 4a du. Now we would worry about the bounds that we should put here. So as x approaches as x approaches 0 from below, I should have, yeah, I wrote it here. So we're going from infinity to 0, thus we're approaching 0 from below. And my bounds here are going to be from, if you plug it, so where's my x here? So 1x here is going to be half u plus root u squared plus 4a, and the other is going to be half u minus root u squared plus 4a. If you approach, let me find it here. So this is my u. If my x is negative infinity, you plug in negative infinity here. You're gonna get negative infinity and 0, because we are approaching 0 from the left, from negative infinity. So we are approaching 0 from below. This term here, let me show it here, because we are approaching x infinity from because we are approaching from below. This whole term here is going to become infinity. So here I'm going to put my bounds infinity, and if we apply the same logical and behavior approach, you're going to get also negative infinity to infinity for this one here. It's really hard to explain it in this video, because I want to keep this short. If you have problems with the boundary changing in this integral and don't have any idea what does approaching from left to right or right to left means, please watch the calculus videos and the end behaviors, because I want you to do this bounds yourself. I don't want to make this video complicated. But anyways, my I is going to be negative infinity to infinity, because the bounds are the same, and the integral is added up. I can add up this integral as half f of u times 1 minus u over root u squared plus 4a plus 1 plus u over root u squared plus 4a du. These two are going to go away. These two actually I was supposed to, this is going to make 1. These two are going to make 2. Sorry, yeah, these two are going to make 2. So I'm going to have negative infinity to infinity of 2 over 2 f of u du, which is from negative infinity to infinity f of u du. Thus, the integral from negative infinity to infinity of f of x minus a over x dx equals the integral from negative infinity to infinity of f of x dx. For example, if you remember this integral that I solved in my other videos, negative infinity to infinity of sine x over x dx is equal to pi, which is equal to, if we apply the same logic here, sine of 1 minus 1 over x over 1 minus 1 over x dx. And this is one way that we can use this logic here. So again, I encourage you to go and see the end behaviors and boundary change conditions if you do not understand it. And the whole thing was just a special case of this theorem, because this theorem is very long. And let me know in the comments what you think, and I'll see you next video.